Good morning, all of you, my dear students. Welcome back in the revision video of chapter number 5. Just now, before one day, we have started the chapter number 5. In this chapter number 5, the chapter starts from Faraday's experiment. Clear? And from that number of experiments, if it is asked in your exam, then which experiment you have to discuss, let us see in this video. Clear? So, it is Faraday's experiment on electromagnetic induction. Right? Means question is like this, explain the Faraday's experiment on electromagnetic induction. Then after that all experiments, this experiment you have to discuss. It is of 2 mark question. Clear? Okay. See, we have to take a coil which is made up of soft iron. This coil is connected with a galvanometer, right? Initially, galvanometer shows zero reflection. It means electric current passing through the coil is zero. What is the use of galvanometer that we have seen? Right? Galvanometer is used to detect as well as to measure the electric current. And galvanometer is so sensitive about that electric current, it can measure 10 to minus 11 ampere electric current. Means a smallest value measured by the galvanometer is 10 to minus 11 ampere. Okay? Not only that, the galvanometer can be converted into that voltmeter as well as ammeter by joining shunt and by joining RS respectively. Clear? If you want to convert galvanometer into ammeter, then you have to join that low resistance in parallel to the galvanometer. And if you want to convert galvanometer into voltmeter, you have to join high resistance in series that we have seen in previous chapters. Clear? Okay. So, this is a coil which is made up of soft iron core. The galvanometer is connected to that coil. Clear? So, here, what to write? How to write? Consider a coil which is made up of soft iron and it is connected with a galvanometer. Now, take a bar magnet, okay, whose north pole is towards the coil. Magnetic field lines are coming out from that north pole. Right? So, initially, the magnetic field lines are not linked with a coil. And because of this reason, suppose we are talking about A. Right? So, at this point, at this moment, means when there is a condition like A, so magnetic field lines are not connected with a coil. Right? So, here, field lines linked with a coil means you have to write like this way, as shown in figure A, the magnetic field lines are not linked with a coil, and because of this reason galvanometer shows zero reflection, and if galvanometer shows zero reflection, then electric current passing through the coil is zero. Clear? So it is a short key. Now what to do? You have to move a magnet towards, right? You have to move the magnet towards the coil. When you are moving the magnet towards the coil, and after some time, the magnet will be like here. So, the magnetic field lines which were not linked previously, but while you have moved this magnet, so all the magnetic field lines got linked with a coil. Right? At this moment means at the moment B. What would happen? Right? So at this moment, right, galvanometer which shows zero deflection previously, now it shows deflection in any one direction. Right? What about that direction? What about the direction of electric current produced? That we will see later on. Right? So galvanometer shows deflection. It means electric current induced in a coil. Clear? Now, according to the Faraday's law, the change in magnetic field lines is required. Right? So because of that, now again inverse process. Right? Move that magnet away the coil. When you are taking away the coil, so the magnetic field lines which were linked in a coil, now they move or they will come out from the coil. Clear? So in both the cases, when there is a motion of a magnet, right, the magnetic field lines linked with a coil changes continuously. Right? So when we are moving away, so let us consider it is a case number C. In case number C also, the galvanometer shows a deflection, but that deflection is in opposite direction. In this case also, electric current induced. Right? Clear? So, these two cases, that means B and C. In that B and C cases, what we have done, there is a motion of a magnet. Right? And because of this motion, as I have shown earlier, the magnetic field lines link with a coil changes continuously. Clear? So, due to the motion of a magnet, magnetic field lines linked with a coil changes continuously. Right? When the magnetic field lines linked with a coil changes continuously at the time, right, galvanometer shows deflection in both directions. Right? So, there is a deflection in which galvanometer, and due to this deflection, we know very well, right, if galvanometer deflect, it indicates that electric current I induced in a coil. Clear? So the electric current which is induced in a coil, this electric current is known as induced current. Clear? This induced current, it produces, what it produces? It produces EMF, right? And that EMF is known as induced EMF. And the entire process, that means this process, the entire process, which process? To induce electric current with the help of magnetic field is known as EMI. EMI means electromagnetic induction. Then after you have to give the conclusion. You have to give the definition of electromagnetic induction. So definition is very easy. How? Let us see. Due to the motion of a magnet, magnetic field lines linked with a coil changes continuously. Right? Due to change in magnetic field lines linked with a coil, galvanometer shows deflection. It indicates that electric current produced or induced in a coil. The process of producing electric current with the help of magnetic field is known as electromagnetic induction. And the electric current which is induced is known as induced current. Due to this induced current, EMF produced in a coil, that EMF is known as induced EMF. And the entire process is known as EMI, electromagnetic induction. Right? So this is the answer of a question. Which question? Explain Faraday's experiment on electromagnetic induction. Clear? Have a look for few minutes. It looks very nicely colorful. Okay? Have a look. Complete? Okay. Yesterday we have seen number of experiments, right? So it was one of that. Okay? I think so. We have taken two magnet. Clear? Here there was a soft iron core, and here there was galvanometer. Clear? So it is like this actually. In this experiment, there was a motion of upper magnet and galvanometer shows deflection. Electric current produced. So keep at that word. Which? Motion. Clear? In just we have seen when there is a coil and a magnet. Okay? So here also there is a motion of a magnet. are moving magnet or coil, doesn't make any difference. EMF will be generated. Electric current may be induced. Maybe not, must be induced. So means there is a motion of both of any, that is coil or magnet, right? And this motion of coil and magnet is in which direction? Opposite direction. Again, motion. We have seen one more experiment and it was like this. Let us consider two coils of same dimension. First coil is connected with a battery, right? Another coil is connected with a galvanometer, right? When electric current passing through it, magnetic field lines linked with a coil number 2, right? And because of that, again, you have to move any one of the coil. Clear? So, again there is a word motion and there is one more thing. There is a 1, 2, either coil or magnet, 3, move any one coil, 4 and 5, and there is one more thing, or change in dimension of coil. If there is a change in dimension, again there is a one word motion, right? Means you have to make the arrangement of that two coil, any one coil, change the dimension like this: compress, expand, compress, expand, compress, expand. So there is a motion of a coil, right? There is a motion of the dimension of a coil. Dimension of a coil changes continuously. Because of that, the magnetic field lines linked with a coil changes continuously. And due to this change, electric current produced. Right? Dear students, here motion, motion, movement, motion, movement, motion, motion, what is there? So, due to the motion, electric current produced. Right? Now, there is the main thing. Due to this motion of any, motion of any means here magnet is moving, here magnet is moving, coil is steady, or coil is moving, magnet is steady. In the system of two coil, any one coil is moving in opposite direction. Here also the dimension of a coil changes, right? Due to this motion, electric current induced. This induced electric current produce EMF, right? So this EMF indirectly is due to that motion, right? So there is a one more definition. Which definition? It is about motional, EMF, right? What is motional EMF? The EMF produced due to the electric current which induced by any kind of motion. Such EMF is known as motional EMF, and you can produce motional EMF by these following ways. First, second, any one. Third, by by moving any one coil or by moving both the coil and change in direction. So these are the ways how to produce motional EMF. So answer is here. What is motional EMF? So definition is here. Hope you have enjoyed this video. Thank you. See you again. Thanks.